Hello everybody. In this session we are going to talk a bit about the rationale behind choosing an electric system instead of a mechanic system. And when we look into this mechanic versus electric, we will as well touch a bit on the hybrid solution where you have both electric and mechanical transmission. First of all, we need to say that the term hybrid may mean different things to different people. And we see that in different magazines, presentations, the word hybrid has been used for different sort of setups, designs and technologies. So just want to highlight that for you. The word hybrid doesn't mean one particular thing. Hybrid means a mix of two different types. And if we talk about the transmission, we may talk about electric transmission and mechanical transmission. And that is what we are going to talk about today. Okay. In the world of marine industry, vessels, we know that we have a propeller, and we want to move that propeller. We want to give that propeller RPM so we are able to move the vessel. And if we can give this device RPM in the most efficient way, then we know that we have an efficient setup of a system inside the vessel. So keeping batteries and energy storage out of the picture for the time, then we need to look at some sort of rotating machinery providing us with the power that we need. So let's make a sketch of some sort of fossil fuel engine, maybe LNG, maybe diesel, heavy fuel oil, whatever. Anyway, fossil fuel has still more energy dense, is still more energy dense than the batteries. So to move a vessel long distance, and to move a vessel traveling a long distance, transporting its own energy, it's still the best way to have some sort of fossil fuel, because the battery, the energy storage in battery is still far away from the energy density in fossil fuel. So I believe for vessels sailing long distance, we still for many years need the fossil fuel like LNG, heavy fuel oil, marine gas oil, marine diesel oil. Okay, so we have some sort of fossil fuel engine providing us with rotating power. We would like to bring that rotating power over to this propeller in the most efficient way. Well, the most efficient way is, of course, a shaft. To bring this rotating inertia, the torque, to bring that over to the propeller, a shaft line. There is almost no losses at all in a shaft line. Maybe some bearings, some lubrication, very, very, very small losses. So if you look at the transmission, this part, a shaft is always the best way of transporting your rotating power from here to here. Okay, but then the question will be, why do we have that many vessels where we specify a complete diesel electric system? Okay, again, we need an engine providing us with the rotational power. And for a diesel electric vessel, or gas electric, but let's say diesel electric, we add a generator connected to the engine, producing electricity. So we have then a cable to a main switchboard, and the propeller is driven by an electric motor. So in a typical diesel electric vessel, we add a frequency drive because we want to adjust the speed of the propeller. Have a look at some of the other sessions where we explain why we do that. So by introducing an electric transmission, we introduce loss, because it's obviously more losses in this transmission than in this transmission. So what is the rationale behind making an electric transmission? Well, again, back to one of the other sessions where we explain the difference between a frequency drive and a starter. Because a starter will give you fixed RPM over here. So let's just take away the frequency drive and add a starter. Let's say a star delta starter. What do we do with the system compared to this one? Well, in this system, the RPM of the propeller is dependent on the RPM of the motor. Hope you agree, because we have a fixed shaft. So if we do not have a gearbox, if the propeller speed is required to be 200 RPM, and we have a big slow speed engine of 200 RPM, then the RPM over here is equal to the RPM over there. So engine RPM equals propeller RPM if you have a shaft line like this. For many applications, we have an engine that have another speed range than the propeller. In that case, we have to add a gearbox giving us maybe a medium speed engine or a high speed engine. Let's say 750 RPM or 1800 RPM. Still, the typical RPM over here is 150, 60, 200 RPM in that area. In this case, the propeller is still dependent on the engine RPM. You agree? However, it is with a factor within the gearbox. So we need some sort of a factor inside here. But still, there is a dependency between the engine and the propeller RPM. That situation of dependency between these two gives us some challenges when it comes to the efficiency in low load situations, and due to the fact that the engine and the gearbox normally has a shaft generator over here. But let's discuss this a bit. The propeller, if you are sailing a distance from A to B, and that distance is what you do with your vessel, and let's say that's 1 day or more. Then you travel with a propeller speed at the optimum for the whole day long. And you have a short period of maneuvering in each end. Okay, the very best way to drive this vessel from A to B is to have the optimum propeller speed at the optimum engine speed and just sail from A to B day out and day in, back and forth. The best way to move your power from here to here with low loss is to have the shaft line. Okay, so again, why do we then have an electric system? We have put it here a starter instead of a frequency drive. And to one of the other sessions, if you have a starting device as a starter here, your motor will have fixed speed based on the frequency in the switchboard, the speed of the generator, and the speed of the engine. If the engine is high speed, 1800, then you have 1800 RPM on the generator, then the frequency will be 60 Hertz on the switchboard, then the frequency will be 60 Hertz on the motor, then the motor, which is totally dependent on the frequency, the speed of the motor, the motor will have fixed RPM. So what do you really do from this picture to this picture? Fixed RPM. Well, this is not a wise solution because you only add losses throughout the electric system, but you cannot regulate the RPM on the propeller side. Because the reason behind choosing an electric transmission is to give you the possibility to regulate with a frequency drive the frequency and hence the RPM of the motor and hence the RPM of the propeller. So the reason why some ship owners would like to have a diesel electric system, the reason why in many cases we design a system with an electric transmission is due to the fact that we would like to regulate the RPM of the propeller, independent of the RPM of the engine. Because in this system, we do not have an equation like this. In this system, the RPM of the motor is totally independent of the RPM of the engine. In this situation, the engine may be 1800 or whatever, 750. Then the generator has 1800 RPM. Then the frequency must be 60 Hertz. Then the frequency into the frequency drive must be 60 Hertz. But the output of the frequency drive will be 0 to 60 Hertz. And the RPM of the motor will be 0 to, let's say, 1200 RPM motor. And the propeller will have 0 to, let's say, 180 RPM. Totally independent of the engine speed. That's why we have an electric system in between. That's why we have diesel electric vessels. Because we really, really want to regulate the propeller RPM independent of the engine RPM. You may argue and say, well, this solution, you may regulate the propeller RPM by regulate the engine RPM. Yes, of course you can. You will of course regulate the propeller RPM by regulate the engine RPM. However, two things. You're not able to go all the way down to 0 RPM as long as the engine is running. You will never go lower than idling of the engine. So the propeller will still have RPM even though you don't need it. So in some situations where you don't need it, you will have RPM due to the fact that this one is, you cannot go below idling speed. The second thing is that when you have one big engine or two big engines, if you have two shaft lines, it is very wise to produce the electricity with the same engine. Therefore, mainly and mostly all vessels have the generator connected to the gearbox. And suddenly you have to have fixed speed on the engine. Why? Well, look at some of the other sessions. I have told you that this generator produces frequency based on the RPM. So if we need 60 Hertz frequency on the electric system, then this generator has to have stable RPM, 1800, 1200, whatever, just pick and choose. Let's say 1800 RPM. And for this generator to have stable RPM, this engine has to have stable RPM as well. Let's say 900. And when you have fixed RPM, due to the fact you're producing fixed frequency, you will have a propeller of fixed RPM as well. And we have in one of the other sessions talked about what does that mean when it comes to losses. You have losses in low load situations. So if you have a vessel where you need to operate the propeller in low thrust, then you have introduced losses that you can remove by going to this solution. Because with this solution, you can adjust the RPM to exactly the thrust that you need. And if you spend a lot of time with low thrust, then you should be able to regulate the RPM on the propeller side. So I said, this solution is the perfect solution if you're sailing one day or 1 week or 1 month from Shanghai to Rotterdam, let's say. This is the perfect solution because there is almost no need at all to go with a low load or low thrust situation. That's only when you have reached the harbor and you start maneuvering. And if you calculate how many hours is that compared to how many hours you are sailing, then you have a comparison. Should we introduce this loss to avoid the loss only for a few hours maneuvering? Well, then you need to calculate how many hours sailing compared to how many hours maneuvering, and how big losses do you introduce compared to how big losses do you remove. So that is the rationale behind when shall I pick this solution and when shall I pick a diesel electric solution. So with this solution, we do not have an A to B sailing typically. However, will you say a ferry, a short distance ferry? Many of them have diesel electric setup. That's correct. And that's maybe because a ferry is sailing A to B, but maneuvering and accelerating and just a short distance full speed and then start maneuvering again. So the time you are utilizing your propeller at variable load and low load is in fact quite big compared to the time you're sailing. So this is the this is the calculation you need to look into. Do you really want to add some electrical losses? Well, we add some electrical losses in this short period because we save so much propeller losses during these two periods. And that's why we pick a diesel electric solution on board a ferry, short distance ferry. If the ferry is sailing one day or several days, well, then we may have to look at this again. So that's the rationale behind that. Okay. Then the challenge occurs quite often. We have a vessel that have a combination. It is really hard to say if we should pick this solution or this solution, because we are sailing quite long distance, but we have a lot of maneuvering as well. In some vessels, let's say a tug or an anchor handler, you may need a lot of power for a short period of time. And the rest of the time, you're just idling, sailing slow speed, waiting, standby. Well, in all that situations, we should really have an electric solution to bring down the losses of this big propeller that is prepared for a bollard pull situation. Or you may have a fishing vessel where you have a big propeller, a bollard pull to pull when you are catching the fish, and you may need a lot of power when you're bringing a fully loaded vessel back to shore with the catch. However, when you are sailing empty, when you are idling around searching for fish, standby, well, then you certainly would like to regulate the RPM of the propeller down to save a huge amount of fuel. Then we are talking hybrids. We're talking a hybrid installation with the transmission. And how do we do a hybrid transmission? Let me keep the hybrid solution away from the full diesel electric and the full diesel mechanic solution. So, hybrid. Okay. We still need a propeller, or two of them, maybe. So let's say we have an anchor handler or a tug. You need a big propeller. You need a lot of power when you are pulling something, anchor handling, or you are pulling a platform, pulling a vessel, something like that. You need a lot of power on your propeller. So that's why we need a big engine. We need a big engine and a big propeller, and we need to bring that energy to the propeller in the most efficient way, and that is through a shaft line. However, many hours throughout a year, this tug will be idling, standby, waiting, sailing, slow speed, and you don't need more than, let's say, 30%, maybe 20% of the big power you have installed. So in all those situations, in all these hours of low load, your big engine will be running at low load, not good. Your big propeller will be running at low load, really big losses. Okay, what do we do? Then we make this an electric vessel as well. So we clutch out and stop the main engine. We stop the main engine. We have a generator already connected to the gearbox because we produce the electricity in normal conditions when the engine is running. Then we produce energy for the propeller and to the generator and provides light and heat and whatever you need for your hotel load. However, when we want to go electric, full electric, we stop the main engine and we use the generator as a motor, giving that generator 0 to 60 Hertz from a frequency drive. That frequency drive is connected to a switchboard, and you have a small generator and a small diesel engine, much cheaper to run than the big one in low load situations. And by the frequency drive, 0 to 60 Hertz, you suddenly have 0 to, let's say the generator is 1800 RPM. You have 0 to 1800 RPM, and your propeller is then suddenly 0 to 180 RPM. When you are running this electric, you have full control of your propeller, and you can regulate the propeller speed from the electric system and drive it maybe up to 30%, let's say 50% of the design power of this system. Then, if you look at the propeller curve, you will save a lot of the propeller losses by being able to reduce the RPM. So when you reduce the RPM, you're able to take away a lot of propeller losses. And those losses are so big that you do not add total losses by adding the electric losses. You add some losses here, but you avoid a huge amount of losses there. That's why this is a wise solution. And then when you have idling around, you have been standby, and you suddenly got the task to pull a big vessel with this tug, then you start up the big engine and you have all the power that you need for the pulling situation. In fact, with a system like this, which we call a hybrid system, with a system like this, you could, in fact, install a smaller main engine. Because during those few hours or few percentage of your operation, during those few hours, you need really maximum power. You could add some power from the electric side. So let's say this propeller is 3 megawatt. In normal installations, you will then have an engine of at least 3 megawatt, because you are producing energy for the 3 megawatt propeller and you are producing energy to the electric system. However, if we have a diesel electric system, hybrid diesel electric and diesel mechanic, then you suddenly can, let's say, have an engine of 2 megawatt, and the last megawatt to make 3 will come through the electric system, 1 megawatt. 1 plus 2, then you have 3 megawatt throughout the shaft and all the way to the propeller. You can save some capex. You will save operational expenses due to the fact that you're able to switch between the main engine and the electric transmission. So this type of hybrid setup is very typical in many vessels. Very typical in anchor handlers, maybe not in smaller tugs, because a tug normally have not enough running hours to save so much fuel from the savings that he can really put money into the investment of the electric part. So I mean, if the tug only operates a few hours per year, maybe a couple of thousand hours, 2,000 hours per year, well, then you may have to calculate, do we really save enough to pay for the capex of the electric part? Maybe not. So then you can just stick with a mechanical solution. But for many vessels, fishing vessels, big anchor handlers, those type of vessels, they would like to see a solution like this, a hybrid solution. Even cruise vessels, RoPax vessels are looking for solutions like this, because they are sailing long distance, maybe for days, but suddenly they are entering into a narrow area, or they will be idling for some days in a fjord or somewhere near to the coast. Then they would like to stop the big engine, because it's not economical good for them to run the big engine and the big propeller at fixed speed. So then they would like to stop the big engine and have an electric system to run the vessel during this idling low speed situation. So maybe during maneuvering and standby, they would like to have a solution where they can go electric. For a yacht, maybe as well. A yacht needs then a big engine to achieve full speed for some days moving the vessel, but then when they are idling around near to the coast, then they would like to stop the big engine and just start a small engine and be idling electric. Diesel electric, diesel mechanic, both solutions in the same vessel, then we have a hybrid solution. Okay, so I hope that was at least a bit more explanation to the rationale behind choosing an electric solution compared to a mechanic solution, and why we pick the hybrid solution. And it's always wise to bear in mind the propeller curve, because the rationale behind going from mechanic to electric is based on the losses on the propeller side. So have a look at propeller curves, look at the curves in different sailing speeds, in different pitch on the propeller if you have a pitch propeller. With this solution you could easily have a fixed pitch propeller as well, even though a combination of pitch control and RPM control is the optimum solution. You can have a fixed pitch propeller here as well, because you can run the motor in both directions from the frequency drive, so from 0 to 1200 RPM in this case, in both directions. But have a look at the propeller curve and you will easily see that you will spend a lot of energy just by rotating the propeller. Even at 0 pitch, even when the blades are really at 0, you spend maybe 15 to 20% in loss. That's a lot at low load. However, if you're sailing at full speed for days and weeks, so your propeller is operating at full speed, optimum design point, well, then the shaft line is obviously the best. So when we are talking about electrification, I don't believe that we are going from a shaft line to an electric solution for every vessel in the world. That would never be wise. It is wise for us in Rolls-Royce to be a partner with the customer and to discuss with him what is the best solution for you on this vessel. And we have both solutions, so we don't need to push them into the electric solution or the mechanic solution. We can discuss with the owner and find the really best and optimum solution for his vessel, for his duty, for his sailing distance, and for his operational profile of the vessel. We can be the partner and discuss all these topics due to the fact that we have mechanic solutions, we have the electric solutions, we have the hybrid solutions, and we even have some of the best hybrid solutions, which you can look at in another session as well, where we will discuss the HSG, the hybrid shaft generator solution, which is in fact a further development of the typical hybrid solution. This is not a rocket science solution. This is something that almost every electric system provider can do. But I believe Rolls-Royce, we have everything. We have high-speed gensets, we have the frequency drive, we have the switchboard, we have the generators and motors, we have the control system, and we have all the automation. We have the propeller, we have shafts and engines, and we have everything. So I believe in discussions with the ship owner, we should be the best, partnering with them, and they can look at the profile and we can discuss what is the best solution. We don't need to push an electric system. If you need a shaft system, that should be chosen for your vessel. So that was the message in this session, and hope you enjoyed and that you can use the knowledge in your daily work in Rolls-Royce. Thank you.